Okay, so last week we talked about. So last class we talked about conic sections today, and then on Tuesday we're going to talk about some circles and properties of circles, okay? So I have 5 different properties we're going to talk about first, and I created this little note section for you. Okay, so the first one we're going to talk about is an inscribed angle. Okay, so if you want to, you can just put like definitions, you can draw pictures in here, whatever you feel like you need to do. Okay?
I don't have pencils. I think I forgot. Can I go to the office and get a pen?
Yep, I'm starting. Okay, so an inscribed angle. Okay, so if we look here, so let's first talk about a central angle, and then we'll see if you can see the difference. Okay, what do you think a central angle is?
Like, is it the angle from this side to the center to another side, or something like that?
So what do you mean by side?
Like, that part.
So we call this part, so that's kind of good. So let's talk about some terminology first. So we call this point, remember the definition of a circle, it's all the points that are the same distance, right? So these would be on the circle. So when you're talking about this part, this would be on the circle, and then this would be in the circle. This would be the center, and then this would be outside the circle, okay? So you're correct. So a central angle is going to be where the angle, so what do we call that part when you have like an angle that has, you know, kind of looks like a V? What do you call that corner part? Close. That's plural. So one is a vertex. So the vertex of a central angle is going to be at the center of it. So that's a central angle. Does that make sense?
Yeah.
Okay, so now I can.
Is it still recording right now?
Huh?
Is it still
It should.
recording?
Yes.
It's behind them.
Yeah. Yeah, I think it is just not there. It's just every time I click it, like.
It changes the tab that you opened.
Right there. Yep, still going. Okay, so there's a central angle. Okay, so notice we have arc BD. So what would arc BD be?
The side.
The arc from point B to point B.
Good. So a piece of a circle is called an arc. So we would have arc BD. Okay, so the central angle makes it. So we notice that our central angle has a measure of 108.59 degrees. That's a random one. All right. So now an inscribed angle. What do you think an inscribed angle is going to be? Okay, just anywhere in the circle?
Out. Is it the?
Inscribed.
Is it the one that is?
Oh. Huh?
So an inscribed angle, where's the vertex?
On the circle.
On the circle. So when we inscribe something, a vertice, that means the vertex or vertices are always on the circle. So we can inscribe where we put things inside a circle, and the vertices have to be on the circle. Or we can circumscribe where we put something outside the circle and all the vertices touching it. Does that make sense?
Yeah.
Okay. So this is an inscribed angle. So the vertice is on the circle. I think it lets me. Yeah, so I can like move it around. So this one's always going to stay. Flip it down here, it switches, right?
So what determines the 2 points that are connected to it on the circle?
So it's just however it's drawn, but like it draws straight out. So this angle, it comes to like.
It's gonna be an angle that it equals like.
Right. Yeah. It'll be anywhere from 0 to 360. Yeah. Okay. So let's talk one more thing about central angles, and then we'll come back. So notice central angle and its arc are the
Same.
That's always going to be true, because remember how you can take an angle and when you like,
Oh, they're just dilations.
it's just dilations of it. I could shrink. All circles are similar, right?
Uh-huh.
You can shrink them, you can enlarge them, and they're always similar. They're just a dilation of it. That's a good way to put it. Angle, and then the arc that it creates is always going to have the same degree. Okay? So let's look at what the inscribed angle is. Do you notice a relationship between the inscribed angle and the...
always
It's
the
half.
same.
It's half.
Yeah, 54 and
Oh, 'cause
108
it's double
and
away
0.59
from it.
is.
Yeah, so that'd be about 0.6, yeah. It is half. It is always half.
Why?
Because it's getting, so from here, that's the center. This is your point of dilation, right? And so that's why it's the same for the circle, because it's similar.
Oh,
But out
that's
here,
twice
you're-
the distance. So
It's outside
Mhm.
the point of the center of dilation, right? I always call this the ice cream cone phenomena, right?
oh, yeah, it kind of
You
looks
see
like
it?
a snow
Yeah.
cone.
So if you look at it, or a snow cone, right?
'Cause the
So the inscribed angle is like the cone, and then the arc it creates is the like snow cone or the
Yeah.
ice cream scoop on the top, right? And so there's always more ice cream or snow cone at the top than at the tip. Does that make sense? So if you want to make a note in your thing, so first of all, you can draw. If you want to draw what the central angle is, if you want to write, if you want to use other angle measures.
What was it? 108.59?
Yeah, you can make it, if you just want to make it like 100 or whatever is easy for you.
Degrees, and then from point.
Yeah, so if you want to
point,
put,
which is B.
so you could draw it however you want. So this would be a central angle. Let's say if I make that 60 degrees, then that makes this arc 60 degrees, right?
I did
So what is the definition? What would you say? An inscribed angle is an angle whose vertex is where?
In the center.
No.
Or on-
Inscribed
is
angle
on the
Oh.
circle.
is on the circle.
Okay.
So then I could make and say, so I could go somewhere down like this, and this would be the inscribed angle. So if I made my central angle 60 and the arc 60, what would be the measure of my inscribed angle?
30.
30.
30. Good.
I did 100.
You did 100? There you go.
I did 100. I was
150.
So we can say the inscribed angle is half the arc that it creates. Or I could say, if I flipped it around, the arc is what?
Twice as much.
Twice the inscribed angle.
Is half.
And the one that goes in the center is called the
Half.
central angle, right?
That's called the central angle.
So
Yeah.
so that's 30 degrees because that's half.
Because it's half of 60, yeah.
The arc. Could you explain to me what the arc is again?
The arc is the piece of the circle that's between the two endpoints of the angle.
Okay, so you take from the center point, you create the angle. The arc
Uh-huh.
is on the circle.
It's the
between
piece
them.
of the circle. Yeah, an arc is a piece of the circle.
So if we were to
Why?
cut the pie, that
Yeah, it'd be like the crust.
Cool.
It'd be like the pizza crust.
I just.
Nope.
Nothing.
Lottie, naughty,
She's
naughty.
nothing.
Okay. Questions on this? Okay, so let's think about, so now our next property we're going to look at is inscribed angles intercepting the same arc. So let's think so if I have, so I'm going to draw an inscribed angle like this, okay? So I'm going to color the green. This would be the arc that it's intercepting, correct?
Correct.
Yeah.
Okay, so now I'm going to draw a second inscribed angle, but it says it's going to do what?
Yeah, I get it. Intercept the same one.
It's going to intercept the same arc. So now I'm going to make like this one come down to like right here. Does that make sense?
Wouldn't those be the same angle?
There you go. So these two angles would have to be the same because they would both have of that arc. Good. Good, good.
Just to make one up.
You can make one up, yeah.
Cool.
So for my rule, when two or more inscribed angles intersect same arc, what's true?
The
They have
angles are
equal
the same.
angles.
The inscribed angles are congruent.
Can never get the squiggle on top to fit just right.
I just like the squiggly tops first.
And is that a rule? So if we had to explain, like, a proof because they intercept the same arc,
Right,
it
yeah.
means that they are congruent.
Yeah, so whatever, if this is x,
Uh-huh.
this would be half of x, this would be half of x. So they would have to be congruent.
Cool.
Okay? Alright. Everybody got this?
Yeah. Uh-huh.
Okay. So I'll show you what that looks like. So the same arc. So there's a central angle, right? This measures 192. So there's one angle, and I can see no matter where I put it, that angle stays the same. Unless if it comes down here and then it intercepts a different arc. So that's why it changes.
Oh, okay.
Okay, does that make sense?
Uh-huh.
Okay, so now if I put up a second angle, notice it's still the same, right?
Uh-huh.
So no matter where I move these, as long as they're making, so like I said, when I move it down here, now it intercepts this really big arc. So that's why the angle changes. So anywhere from here all the way around here, they're going to be the same. Okay?
Mhm.
All right. For this next one, we're going to do an activity that kind of goes with it called Thales theorem. Okay? And you're going to need
TH Thales.
Thales. Yep, named after the person. And I'm going to give you a piece of paper. So I took just a piece of paper and cut it in half. I want you to use the half. Can you tell the part that I cut and then the part that's the original piece of the paper? The corner that's the original piece of the paper because I want it to be what kind of an angle?
Right.
A right angle. So if I use the corner, that's going to be a little bit better than the one that I cut. So use, if you want to mark that as like your right angle. Looks like it's that one right there.
Wow.
And then looks like it is that one right there. If you want to mark that as your right angle. Okay? Okay. So
It is so right.
So in that section of white paper that's kind of towards the bottom of it, it says mark points A and B. Okay, so down here, put 2 points that are A and B. And the only thing is it cannot be wider, your 2 points. Okay? So put points A, point B, just as long as it's not wider
Just anywhere.
white paper.
Okay.
Oh.
On the white paper. So in this area, it's the bottom. Yeah.
Any
Okay.
2 points.
Any 2 points. Just make sure they're
It's
not
locked between
wider.
the guys.
Oh. I can let you in. You're not a stranger. You're fine. Okay, so any 2 points. Okay.
A point B.
Alright. So then it says you're going to take your colored paper provided and you're going to push that paper up between points A and B. So, did I make it? Yeah.
Wow.
So between points A and B till it touches, your paper touches each point. And then you're going to mark that point
On your paper.
at the corner. Yep. So it says the
Oh, we're making it a right angle.
So yeah. So that would make a right angle between A, C, and B, correct?
Yeah.
Uh-huh.
You don't draw it, just leave it. Okay? Then it says do it again. So now I'm going to kind of turn it. So it has to stay, but I'm going to do it a different way. So now here's like another point, like right there. That makes sense?
Okay.
And then keep.
Oh, and I'll make the one here. It's good. And then that's weird.
Keep going.
Yep, just make different points.
I'm gonna make like a half circle. That's
You're
weird.
going to see.
Oh wow, yeah.
So it says do this again and again, multiple times. You don't have to label them. What curve do the colored points seem to trace?
A circle, a half circle.
A half circle, right?
Uh-huh.
So if I trace through these and connect them, they are making a half circle. Would that have worked if I used, because we talked about that our paper, we wanted this corner of our paper to be a right angle, right? Would that have worked if it wasn't a right angle?
No.
No.
Why is that though?
Okay, so let's talk about that. Okay. So if we turn to the next page. So it says, in the exploratory challenge, you proved the converse. So the converse is like backwards. So if this, then that. The converse would be then, if this part, then this is true. Does that
If
make
that,
sense?
then this.
Right. So if this, then that. The converse is if that, then this. Good. Okay. So that's that. So Thales' theorem states the following. So here's the his theorem. So a theorem is a property that's been proven true. Okay, so if A, B, and C are three distinct points on a circle, so we had A, B, and then C, and AB was my diameter. This was what I made as the longest distance to go. My paper had to go through it, which created this to be the longest distance, which is a diameter, right? Then ACB is a right angle. So if I have 3 points, okay, and then this is the diameter, then this has to be a right. I did the opposite of it. I said if that is a right angle through 2 points, that's a diameter, then the points are on a circle. Does that make sense?
And that's Thales'
Yeah.
theorem.
That's
To
Thales'
work backwards.
Yes.
So if it makes that, then it's on a circle.
Correct.
That's weird.
Yes.
I mean, like,
So let's, do I want to prove it? Let's see, yeah. Go through, see if we can prove it going the opposite way. So we just kind of discovered it. Let's see if we can prove it. We're going to do proofs this unit. Your test will have a choice of 3 proofs. That would be a level 5 if you wanted to get a 5. So if the proofs like stress you out, confuse you, if you're like, I don't think I can do this, then that just means you're not going to get a 5. You can still get an A, you can still get like a 4.5 and get an A. Just the 5, the 100% is going to be the proof.
4.5 is an A.
4.5 is an A, yeah. For the math concepts. All right. So it says draw a circle P with distinct points A, B, and C on the circle and the diameter AB. So I'm going to draw a circle. Hey, that's pretty good.
well, that actually is pretty good. Dang.
Any other circle.
Or you can trace one of your circles from your other page if you like. All right, so it's gonna have a diameter of AB. So this is A, B, and then another point on the circle C. And I want to prove that angle ACB is a right angle. Oh, so this is circle P. So when they tell you that something is like circle P, that's telling you that's the center of the circle. Okay?
Oh. And that's good. C is gonna be a right angle.
Well, we're going to prove that.
Well, yeah, it would have to be.
So we're going to prove why it's true. Okay? So it says we're going to draw a third radius PC. So I'm going to draw, if you want to make it like dashed, there's another radius PC. Okay? So what type of triangle is triangle APC?
It.
Can't remember what they're called. It's like all acute angles.
Okay, so that'd be just an acute. But let's go. PC is called what? What's the segment called? A radius. What is PA?
Another radius.
Another radius. So if the triangle has the 2 radii as the sides, what do I know about this radius and this radius?
They're the same.
They're the same, right? So this radius and this. So what kind of triangle now is APC?
A right triangle.
No,
No, not a right triangle.
Equilateral.
no,
Equilateral.
not equilateral means
Also,
3.
All 3.
I don't know if this one is isosceles.
Isosceles. That's what it is.
because it has two congruent sides that are the. So anytime you draw a radius in a circle, right? All the radius, because that's the definition of the circle. It's equidistant. It's all the points equidistant. The radius always has to be the same length, right? And then if I look at triangle BPC, so we said PC is a radius. What is PB?
Diameter.
Nope.
No.
PB.
Oh, radius.
It's
PB
also
is
a
a
radius. So now what type of triangle is BPC?
Another
Isosceles.
It's also an isosceles triangle.
Isosceles. Such a strange word. Cool shirt.
Thanks. They gave us these at one of the last ones. Okay, so now it says use the diagram that we created to prove Thales' theorem. Okay, so in order to prove that, I'm trying to get angle C to be what kind of an angle?
Right angle.
A right angle. So then that means that I need to show that the measure of angle ACP, everybody see which angle that is?
Yep.
ACP, so we're talking about this angle, plus the measure of angle BCP would have to equal how much if I wanted it to be a right angle?
180.
No.
No.
360.
No.
Wait, so,
Like that.
oh,
90 degrees.
BC.
Uh-huh. What?
90.
Oh, BCP. Okay, that one. 45.
So no, not that each of these, but these two together. So this angle and this angle together
Is 90.
is 90 degrees.
Because it started out with a right angle. Or we're trying to
Right.
prove that. I mean, I drew it using the paper. We're using Thales there. We're working backwards.
We're trying to show. No, we're not working backwards. Working backwards would say we assume it's 90 degrees. We're trying to show that it is 90 degrees.
Why did we write the M and then the angle?
The measure.
Oh, okay.
1 degree, one is talking about the actual shape.
Cool.
Okay, so it says label the base angles of triangle APC as B. What do I know? So here is triangle APC, this one on the left. What would be considered the base angles of the isosceles triangle?
Angle P to A.
No, not P and A.
Wait, what's the base of the isosceles?
Uh-huh.
AP.
No, the
Of
base
each one?
angles.
Oh, the base angle.
Oh,
So if I have
excellent.
an isosceles triangle, that means two sides are the same, right? The base angle, so it can be turned, like it could look like this, right? The base angles refer to the two angles that are opposite your congruent sides. So that would be this one and that one. What do I know about the base angles of an isosceles triangle?
They're gonna be the same.
They're going to be the same, okay? Because if the lengths are the same, they have to open up the same amount, or vice versa. So up here, like these would be the base angles, correct? So what would be the base angles for triangle APC?
A and C.
A and C. So, and we know that they have to be the same. So I'm going to call this guy B, and I'm going to call this guy B. And then it says the base angles of triangle BPC as A.
Yes,
So that'd be this angle and that angle, correct?
Yeah.
So now it says express the measure of angle ACB in terms of A and B. So ACB would be these two what?
Angles.
And how would I get the total angle? What would I do with them?
Add them together.
Add them. So measure of angle ACB would equal A plus B, correct?
Yes.
Okay, so I want to show that it is a right triangle. So that means I want A plus B to equal 90 degrees. So I want to prove that angle A plus B is 90 degrees. Okay? Does that make? What do I know about all four of these angles together?
One big triangle.
One big triangle. What do all the angles in a triangle?
Add up to
Add up to
180.
180, right? Angle plus the second angle plus the third angle has to add up to equal 180 degrees, right?
Uh-huh.
So angle A, we said it has a measure of B degrees, correct?
Uh-huh.
So that one is B. Angle C, we said was what?
Was
Both of those added together. So B plus A or A plus B, either one. And then the third angle in my triangle is
Angle B.
No.
No. What
Yeah.
is that?
uppercase B. The angle
A,
is,
A.
yeah, the measure is A.
Oop.
So confusing. They should have used X and Y. Okay, so now can I simplify this?
yeah.
Yeah,
Yeah.
so I have how many A's?
2. and
2 A's plus 2 B's equal
1.
degrees.
What happens if the base angle is not on angle C?
Well, we made it. We drew it. So we drew the 2 radius so that way, and it'd have to be. So if like my triangle's down here, I'm going to draw my radius to that right
okay.
angle that I'm trying to prove.
Okay.
So now, can I get rid of these 2's? Can I simplify it?
Yes.
Yeah.
I can divide everything by what?
2.
2. So A plus B equals 90.
So A plus B has to equal 90.
Oh, we just proved it.
We just proved it. Yeah?
Yeah.
So we can put these 3 dots. I'll put that there. You know what the 3 dots mean?
Triangle.
The
No.
points on track. It's
Therefore.
Oh.
That's what they're there for.
Is that like what? I've never seen it before.
You've never seen that before?
No.
Therefore, is 3 like alien dots. They look like the lasers that Predator shoots at people. There.
In logical arguments and mathematical proofs, the therefore sign is generally used before a logical consequence.
That's cool.
Learn something new. So now we can go back. Everybody got this written down? Okay. So now we can go back and look at our properties of circles note sheet. And now, what can I say about the relationship between an inscribed angle of a semicircle?
The
A
A
plus
plus
B
or
equals 90.
the whatever the
So
angle.
let's draw it. So in
Yeah.
order to create a
It's not like the A
semicircle,
and B.
how do I create a semicircle?
Cut it in half.
Cut it in half at the diameter. So I'm going to draw the diameter.
Yep.
Okay, so there's a semicircle. Now I need an inscribed angle that creates that semicircle. So how would I draw that?
A, B, C.
Right, yep. So I draw that, right? So now I have an inscribed angle. So this is an inscribed angle of a semicircle, correct?
Correct.
And what do I now know about the inscribed angle?
That it is 90 degrees.
It's 90 degrees. Anytime you have an inscribed angle of a semicircle, its measure is always 90 degrees. Also known as Thales' theorem. And the converse of it's true too. If you have a right angle, you know its endpoints have to be on the what?
On the diameter.
Mm-hmm. So if you have a right inscribed angle, its endpoints are on the diameter.
What does it say? Or if a right.
Or if, yeah, or if a
Okay.
right or if, I think I was going to say, or if you have. You can just put or a right.
Anytime.
There we go. Or a right inscribed angles endpoints are there.
Now, like, is that a rule? If we're gonna have to prove, are we gonna have to prove that's 90, or is it just accepted that it's always 90?
It's accepted. Yeah.
Cool.
So you can also think about it this way. What's the measure of a semicircle?
180.
180. Is that considered assuming something, or is that something we know to be true?
That's something
That's
you
true.
know to be-
It's
Always.
true, okay?
So,
So you can't assume something looks like a right angle unless if it tells you. But if you have a circle and it shows you the diameter, and the way you know it's a diameter is they're going to show you the point. So if they draw
Someone's at the
something,
door.
it's Miss,
That was
Oh,
a
that's
substitute one time.
yeah, it's Miss
uh-uh.
Cash.
Okay, I'm not gonna mess with that. So if they draw a circle and they draw a line like this,
Uh-huh.
and the line goes through the center, you can't assume
It's the
it's the diameter. In order for it, so even though that doesn't look like it's the diameter, if I put this,
Oh, it's a diameter.
it's the diameter. Or
Like
the
a
Pokemon.
Pokeball. Yeah.
Oh god.
Okay?
No.
So because I know that something is a diameter, it's 180 degrees. Thus, the inscribed angle has to be,
90 degrees.
what was the relationship? 90
half.
degrees, half.
Always.
Good. Okay? All right, questions with that?
No?
I'm Miss Cash. I'm the substitute for today.
Oh, okay. I think you're in the middle room, I think is where,
Spanish.
math.
Oh, right. Who would teach in there?
Huh?
Who would teach in there normally?
Well, Mrs. McKay, she's not substituting for Mrs. McKay. She's substituting for the special ed teacher that goes in and sits in the classes sometimes.
Oh.
Okay? All right, I'm going to
Yeah.
stop because I'm going to have to, upload. So I'm going to stop this video.